Welcome to CommercialDrones.fm, the podcast that explores the commercial drone industry, the people who power it, and the concepts that drive it. I'm your host, Ian Smith. Hey everybody, before we get started, I want to let everyone know that we hit our first Patreon funding goal. So this means everyone from here on out that donates $1 a month to the podcast gets an exclusive invite to the private, patron-only Slack group that I created to discuss everything commercial drones. So you can get your invitation to the group by visiting patreon.com/dronespodcast. That's patreon.com/dronespodcast. And just by donating $1 a month to the podcast, you're in. Okay, so welcome to Commercial Drones FM. Now that that's over with, thanks everybody for listening and tuning in. So this evening, we're sitting in San Francisco at the Drone Deploy offices, and I am here with Alex Harmsen, who is the CEO and co-founder of Iris Automation, which is a drone startup out of Y Combinator that recently raised $1.5 million in seed funding to bring sense and avoid technology to drones used for industry. So thank you so much for coming and being here with us this evening, Alex.
Glad to be here, Ian.
Appreciate it, man. So let's get started. Let's kick this off with a little bit of backstory. So we met actually previously at an Orange Silicon Valley event, Orange as Americans would say, like the telecom company. And they have like a venture capital arm that they have here in Silicon Valley. And you were speaking on a panel on, it was like artificial intelligence in drones or something?
Yeah, I think so. It was artificial intelligence, machine learning, in general, how drones can be smarter, how that's changing over the next few years.
Nice. Yeah. So we met at the little, cocktails afterwards. In typical French fashion, there was some cheese and wine. It was really nice. So at that point, after hearing you on the panel, I knew I wanted to get you guys on. And at that time, you had not raised a seed round as far as I'm aware. And you have some big news now. You guys were all over in the news for getting your seed funding of $1.5 million. So congratulations on that.
Yeah, thank you very much.
Yeah, no problem. So tell us a little bit about, first of all, what is Iris Automation? I mean, the kind of tagline, sense and avoid technology for drones in the industry. And I saw one of your investors compared you guys to airbag and seatbelt manufacturers from an earlier generation. So your technology is kind of similar to that. And I guess that means safety?
I mean, a big part of it is trust, I think. In general, like what we've seen in consumer drones and military drones has been this huge uptake, but like that same sort of uptake hasn't quite happened on the commercial or industrial side. And I think a big part of that is it's trust and safety. I think in general, like comparing it to airbags is like quite a great idea just because like airbags are so prevalent and you're not going to find any car today without airbags. I mean, we see that as the future of drones as well, especially autonomous, beyond line of sight. I mean, every drone should have some sort of sense and avoid system on board. And so really at Iris Automation, we're building computer vision based collision avoidance systems specifically targeted for industrial drones.
Okay, cool. Can you explain what specifically makes an industrial drone?
Part of it is size, part of it is cost, but really the big component there is what it's being used for. And so these are drones that are being used for forestry management, agricultural surveys, mining exploration, package delivery, human transportation, even pipeline inspection, anything like this. I mean, we're covering larger distances. We want these drones to be completely autonomous, and scale becomes a big part of that.
And so what led you to create the company, and how did it happen? You're co-founder, so there's another founder involved as well?
Right. James Howard. And so we had met years back in university in Vancouver and in British Columbia. And we had started up this drone team together and grew it from the two of us and a third guy, Chris, to 47 engineers. And we were competing in national competitions. We drove across Canada. I mean, this was very exciting. We were the first team to ever fly multiple drones in the air at the same time. We had a computer vision component to that. And I mean, it was sort of like a small company. I mean, it was 47 engineers, volunteer bases, and we built, I think, 8 different drones over those years. And
dang.
I mean, he went off and worked at Spire and Boeing, and I worked at Matternet, NASA. And at a certain point, we always just stayed in touch. And we saw this growth in the drone industry, and we were both really excited about aerospace in general and robotics, and essentially saw this huge divide and this artificial constraint on the commercial drone market, and said we should try and figure out how to solve this trust issue. And like ultimately that's what created Iris Automation. At a certain point we quit and moved back up to Vancouver and worked in a basement for a while writing software, and then said, you know what, we have the prototype, and let's get some investment and pour some gas on this fire.
That's awesome. So you're based here now in the Bay Area?
Exactly. So we just moved down. So we came down for Y Combinator over the summer, and such a great ecosystem here. There's talent, investors, just in general, these sort of events, great podcasts.
It's a good place to be a guest on a podcast, and also to get investment for a drone company. Were there other, for those who don't know what Y Combinator is, can you explain what that is exactly?
Sure. It's one of the best known accelerator programs in the world. Essentially, they select a number of different companies twice a year in 2 different batches. And they're brought into Mountain View or San Francisco. And essentially, they bring in mentors, guests. There's something called Demo Day at the very end, where they put you on a stage for 2.5 minutes in front of 500 investors. Was quite thrilling. Probably the most rehearsed 2.5 minutes of my life. But the sort of interest that came after that was phenomenal.
Oh, that's awesome. And how long? So that goes on for like 3, 4, 6 months or something in Y Combinator?
Yeah, it was 3 months, June to end of August. I think the biggest part of it is being part of this alumni network now. And so there's something like 1,000 founders that have gone through that program. And just being part of that network, being sort of on that inside circle has been tremendously useful for contacts, even just asking questions. There's a forum that I could pose any question to, and it could be CEO of XYZ company, or it could be some other founder of a much smaller company that made mistakes 8 years ago and now is wanting to share those experiences.
That's a huge asset.
Huge.
Was being a drone company unique at that time? Like for Y Combinator, were you guys like one of the few in there, or one of the only ones?
I actually don't know if I'd consider myself a drone company.
Ooh.
Really, we're going after that computer vision, the artificial intelligence for these autonomous vehicles. And it makes so much sense to apply that to drones. It makes so much sense to focus on the drone industry. But it's more providing that software, that intelligence for these industrial drones to allow them to do their thing, rather than like being a drone company.
Nice. Good answer. Okay, cool. So are humans bad at piloting drones then? Like, can we not trust humans to safely pilot drones? Is that why Iris Automation and computer vision, all this technology for sense and avoid, is that why it's needed, or are there alternative reasons?
Honestly, I think humans aren't just bad at piloting drones. Humans are bad at piloting manned aircraft too.
That's true. That's very true.
There's so many accidents, and like most National Transport Safety Board investigations essentially call into question human operator competence.
Pilot error.
Pilot errors, the number one cause of any aviation accident anywhere. And like drones are an extension of that. The big issue with drones being operated is like once we want to be able to move to fully autonomous drones for a lot of these applications. It makes sense. It's so much more cost effective. And like these drones are essentially robotic. One of the main reasons why we have these drones is to be able to like extend this human reach, or to have eyes in the sky or from a different perspective. And it's not really natural for the humans to actually be operating them. It's counterintuitive to actually steer them with 2 little sticks with buttons. Ideally, these drones should just be able to accomplish their task without any sort of human interference. And so something like Iris Automation, being able to provide situational awareness, being able to letting these drones see the world the way a pilot would, that essentially gives us the confidence that they would fly those missions without running into manned aircraft or birds or balloons or buildings or
power
cell phone
lines.
Towers.
Yeah.
Whatever have you.
Okay, cool. So So how many employees are you guys at today at Iris Automation?
We're 10 people.
10 people. Cool. And so what is the Iris Automation team like? I mean, are you guys, I'm assuming mostly software developers at this time, but
right.
Yeah, how is the team comprised, and what are you guys kind of working on like currently?
I mean, it's quite a hard challenge, right? I mean, we're talking about outdoor computer vision at a large range in real time on embedded systems. And the computer vision and deep learning itself is like no trivial challenge.
That's attractive though to software developers.
It's super attractive. I think we've got most of the buzzwords covered, which is great.
AI, ML, CV. There you go.
And so, I mean, all of the team is engineers except for one.
Okay, cool.
And so we've really like made that team engineer heavy, just because like we know we're trying to solve a hard problem, and we want to make sure we solve the problem and make the most reliable product before we really start selling something.
Nice. And are you guys looking for other people to join your team? I like to always ask this question because some people might be listening who maybe are curious about joining the commercial drone industry, or we won't call it the drone industry, but for the sake of this, we will. We won't call you guys a drone company right now. But yeah, what's the deal? Are you guys hiring stuff? What are you doing with the $1.5 million? Maybe that's a better question.
Sure. I mean, a big part of it is hiring. And partly it's, keeping that current staff on, and moving us from like our current product, which is like in the field with pilot customers, to something which is actually commercialized, like something commercializable and something we can sell in a much more widespread, like official version. And the other part is, we're hiring a testing and reliability engineer, and we're always looking for more computer vision people, because ultimately, this is where the real magic happens.
Speaking of computer vision, so how are you guys implementing computer vision, machine learning, and AI kind of all together into the drones? I mean, like if you can just describe kind of maybe what's happening behind the scenes briefly, without, of course, revealing any trade secrets and whatnot. But how would you describe that in a medium which is only sound? So people can only listen to this. So good luck.
Really, we've taken a layered approach to that. Really, we have a number of different deterministic like pieces to what we're doing. And like one of the fallbacks of computer vision sort of traditionally has been it fails catastrophically, or machine learning or artificial intelligence in general could fail catastrophically, to go from like 95% confidence to 0. And so there's a certain elements of the system that just can't fail in that way. And this is very important for a safety product, for something that has a big reliability element. And so we've sort of mixed these newer AI deep learning algorithms for classification, for tracking, with these more traditional, more deterministic algorithms that are able to do the sort of 3D reconstruction, the sort of tracking and scene recognition that we actually want out of some sort of safety product. And so that's been very important for us to be able to certify a product like this, for us to actually build something that we can stand behind and say, this is a safe product. This would actually help the drone move forward. And so, part of it is situational awareness. We know a number of different elements about the scene. Part of it is dynamic tracking of objects. And so we're looking at moving objects like birds, helicopters, aircraft at a range of over 500 meters, and trying to figure out where they're going to go. So we're doing robust trajectory planning there. And then so the other element of the system is being able to do 3D reconstruction at a huge range as well, at hundreds of meters of range. Because, ultimately, we feel like the best solution to this is complete situational awareness. And so we want to know, where is everything that's not moving and where is everything that is actually moving, propagate that forward in time. And if we have some sort of collision happening there, then we want to notify the autopilot or the operator.
And how is this actually being implemented? Is this just software on board, or is there a hardware component to this?
Really the magic happens in the software. And so really, we see ourselves as a software AI company. But, essentially you need a camera, a single camera that takes in this video feed, just like any human pilot. And that happens, essentially that's transferred to a processor on board. And essentially that processor is doing all this computation. It's running these algorithms and then relaying that back to the autopilot. And so, I mean, for us, we could sell software licenses. For now, we're also selling the hardware just because we want some computing platform that we know of. But I mean, being able to sell reference hardware or being able to sell the hardware just at cost, just to make it easier to install, is like, we're more than willing to do that.
In the future, maybe like API or SDK kind of compatibility. Are you guys envisioning that at all?
Yeah, we have an Iris API, and then we have a couple like specific hooks for different autopilots on the market.
Oh, that's awesome. And I have to say, are you guys compatible with DJI drones at the moment? Because I mean, they're the gorilla in the room.
Yeah, we are.
Oh, cool. Okay, nice. That's awesome. So, what kind of compatibility does this have? I mean, okay, you did mention like the vision component. Like you get a video feed, and then it's analyzed by the software, which is powered by powerful hardware. Do you have any other sensors involved? Like I'm talking radar or any type of sonar, anything that's, using any other technology?
No, really. Like it's purely vision based. I mean, ideally we use other sensors, and like I would love to do sensor fusion. The issue is that like there's nothing on the market that can sense the sort of range that we want to be able to sense at, or is like anywhere remotely in the price range that we want to be able to sell the system at. And so, I mean, hopefully radar and LiDAR systems like over time in the next 4 or 5 years come down in price, come down in weight, volume, like become more energy efficient, and we could integrate those into the system. But for now, it looks like computer vision is sort of the only solution that would work in this case.
Makes sense. Yeah. Tiny little cameras, they can see really far. They don't weigh a lot. They're inexpensive. Makes a lot of sense.
And the great thing about software is that like we could do a lot of software testing and very quick iterations on this sort of software without doing a lot of hardware testing that is required for radar LiDAR systems.
Yeah, especially every little ounce, every little gram matters, of course, in the small drone world right now. And what about like, are you guys going to integrate as far as with like air traffic control maybe? I mean, are you going to try to, or maybe pull in other sources of information that can aid your technology in detecting and avoiding other aircraft or things in the sky, or maybe just in the general vicinity?
All right. I mean, in aviation in general and more robust robotic systems, like we're always going to get a better solution if we add in different sensors, if we add in different sources of information. So I mean, like we're completely open to that. We're talking with a couple different companies about fusing that information into some sort of grid. I mean, we're part of NASA UTM, which is trying to create this traffic management system. And so to feed into NASA UTM would be wonderful, and it's definitely on our roadmap. Yeah,
bidirectional sync would be great. And as far you mentioned, so that the maximum current distance of detection right now is 500 meters or so, or do you guys? Okay, cool. And that's all just based on the vision and stuff. So if the sensor improves, like if you have more pixels, basically, does that mean better performance necessarily? Is there like a
I mean exactly the same?
Oh, cool.
Like honestly, we could throw a very powerful camera on there and we'd be able to see a lot further. Part of it is like computational power constraints, which also come down over time.
That's right.
Right. I mean, as we get better and better processors, the system just naturally improves. And as we get better cameras, the system naturally improves. I mean, there's some trade-off there right now. And like, we're not even using the most expensive or highest resolution camera on the market. I mean, we really want this to be the software. And I mean, naturally over time, like other factors or smartphones or processing power comes down in cost or increases in efficiency, and essentially we just get to ride those waves.
Yeah. And what kind of like if you look, so there's already some computer vision sensing, products on the market. Obviously there's DJI. They have their vision sensing. Also Intel has RealSense. How do you compare to those products? Like, how does Iris Automation differentiate itself? I guess maybe even from like the industrial aspect. Like, what are you guys doing that tackles the problem or solves the problem differently than those two?
I mean, that's a great question. A question like that comes up all the time, and is, I think for me, like relatively simple to deal with, but it could be hard to just intuitively understand. I think when it comes to collision avoidance in general, or different collision avoidance technologies, we've sort of broken it up into two categories. Whereas Intel RealSense, the DJI Phantom 4 with their collision avoidance, falls into this sort of short range bumper solution. This is 10, 20 meters in front of the drone. Could be multiple directions, but it's really meant for consumer drones. It's meant for sort of very slow, short range navigation. It's meant to fly you through a parking garage or through a forest, or it's special follow me features. It's more interaction with humans, or if you're using it for a wedding shoot, it's there to make sure you don't hit the altar accidentally. But then the other side of that, the other side of collision avoidance is more the sense and avoid technologies. And that's more what we're going after. This is more full range solutions. This is 10 to 500 meter range. Honestly, the point of our system is to make drones boring. I mean, we want to make boring is safe, right?
Yeah.
And in aviation, that's what you want to go for. I mean, it's like certain orders of magnitude higher in safety. We want to make sure that these drones aren't running into manned aircraft. I mean, we want to be able to allow these drones to fly in national airspace, and for the FAA and Transport Canada and whatever other regulatory agencies that feel safe about letting hundreds of thousands of package delivery drones like loose in airspace.
Yeah.
And that's the sort of problem we're dealing with. That's the sort of problem that we're solving with this collision avoidance technology. And I mean, that in my mind, that's a huge differentiator. It's more toys compared to like aviation and avionics.
Earlier, and that's a good point, because earlier you had mentioned, and I'm probably going to butcher this, trajectory computation or something.
Propagation.
Basically trajectory propagation. What is that exactly? So what I imagine is, okay, the camera sees something, your software identifies there's an object and that it's moving, and then it tries to figure out where it's going.
Exactly.
The trajectory.
Yep. Okay. So, I mean, we can recognize what sort of aircraft we're looking at, or if it's a bird or helicopter or plane. And I mean, essentially, we have a number of different trajectory models there. We're looking at like how it may fly through the sky. I think similar to a pilot. I mean, if you were a pilot in an aircraft in a little Cessna and you saw another plane, or if you saw a helicopter zipping along some landscape, you could figure out where it's going to go in the next 20, 30 seconds. And we're doing the same thing. So we're looking at where it is, where it's going, trying to figure out what it is. And I mean, ultimately, as our algorithms get better, we get better and better at this trajectory propagation. And essentially, the more reliably we can project that into the future, the more reliably we'd be able to detect some sort of collision and actually get out of the way.
Okay, so you'll send a command to the aircraft through the system, and it will just move and alter trajectory if it looks like it's going to be a collision.
Yeah, exactly. And that's completely configurable by the user. I mean, some users want to pull a parachute immediately. Some just want to land immediately. Some just want to hover. Some actually want to move out of the way and add a few new GPS waypoints into that mission.
Do you think there could be, once this technology becomes more widely adopted and maybe, UTM is in place and everything, do you think there could be regulations on how far a autonomous vehicle would have to take evasive maneuvers from another object if using a specific trajectory propagation technique determines that there's an X% chance? You see where I'm getting at?
Well, definitely. Yeah. I mean, we're talking with regulators right now about that. I mean, we're involved. I mean, we're on subcommittees with RTCA and ASTM and NASA UTM. We're involved in like drone representation groups in Canada, Unmanned Systems Canada. I mean, a big part of that, trying to figure out how do we integrate drones into the national airspace, how do we integrate drones and have them fly in the same space as manned aircraft, is setting these basic rules. I mean, I fully expect there to be regulations like that. And like every government and every regulatory body we've talked to have said that like you need to mitigate the risk of collision with manned aircraft, or they've said you specifically need sense and avoid technology to be able to do that. The big question right now is what is good enough? What is safe enough? And I mean, as a thought leader in the space, we're definitely pioneering those concepts and proposing certain solutions for that. I mean, it's not something that we're just pulling out of the air. This is We've done a lot of simulations there. We've built a simulator from scratch that allows us to be able to do these tests and allows us to do not just a couple drone flights, but hundreds of thousands of hours of simulations in real world environments. And so it's that sort of robustness, or it's that sort of thinking that actually allows us to build certification procedures. It allows us to actually say this is good enough. Because like as much as we want in aviation, at a certain point we have to draw the line and say like this many accidents are acceptable. And I mean, we want to reduce that as much as we possibly can. And we feel like if you add an iris automation system on board, like suddenly your drone becomes X times better, X times safer. And we know that's going to help in selling to mining companies or oil and gas companies or forestry, or even helps Amazon get their package delivery drones out actually flying in the US.
So different companies in different industries assess risk differently. There are more, higher or lower tolerances of risk. Now you've got me thinking, what if the vision systems trying to detect things not to run into were not just pointing straight ahead, but also pointing down? Like right now you need a special waiver from the FAA in the US to fly over people. Could this technology theoretically be like pointing down and then seeing people underneath it, and then assessing risk that way and keeping itself at a safe distance to not, like, if there was an engine failure, hit the people or something?
Sure. I mean, like really what we're doing is building that software, that intelligence that allows us to do that complete situational awareness. And if we're pointing up, down, forward, backward, left, right, doesn't really matter. I mean, the current implementation of the system is a camera with a certain field of view facing forward, because most drone companies and most regulators are worried about hitting something head on or colliding with something in sort of this essentially going forward limits that time to collision. And so that's the direction where you really want to be looking at. But I mean, definitely there's no real limitation for us to just add more cameras, or like maybe certain drone companies are worried more about stuff hitting them from behind or from the bottom, and you should just point the system in that direction.
I just had a paranoid Big Brother moment where the camera's actually pointing back at the operator, and then if the operator loses sight, if the camera loses sight of the operator, comes back home because you can't do visual line of sight or beyond visual line of sight, that would be just really I'm seeing how this technology matures, and then seeing regulations get bundled in with it. Like, oh, if you're doing this, if you're making this type of system deployed on a commercial unmanned aircraft system, it must be able to ensure compliance with XYZ regulations. That's really interesting.
It's pretty exciting. I mean, we're with Part 107 and sort of like the end of 333 exemptions. There's a whole new set of rules, but at the same time, in this, especially in industrial drones or commercial drones, beyond visual line of sight is sort of the Wild West. It's sort of like we don't really know how that's going to develop, and like we want to be at the forefront of that, or we want to be an enabling technology in that element of the drone space and make those rules, or help make those rules, or suggest those rules, and essentially like see where that takes us.
Yeah. Technology is going to play such a huge factor in that, of course, in computer vision as it permeates the drone industry further. So I have to ask then, Mr. Harmsen, what is your favorite drone of all time and why?
What a great question. So before Iris Automation, I was working at NASA at the Jet Propulsion Lab, and we were working on a project called Mars Helicopter.
Whoa.
And essentially this was a drone for the Martian surface to help guide the Mars rover along the Martian surface. I mean, this was very interesting. We were working on computer vision systems specifically really cool for that drone to be able to do 3D reconstruction of that surface. But I mean, the Mars rover has the same issues that like industrial drones have now. Honestly, it's $2.4 billion, and we just don't trust it to navigate on its own. As soon as it goes beyond line of sight, as soon as it actually lands on the Martian surface, we're worried about it falling off a ledge as high as this table, flipping over, and boom, like people are going to get fired over that. I mean, so there's certain situational awareness like on the Mars rover, but I mean, having some sort of drone that follows it along and sort of gives it eyes in the sky to map out that landscape. I mean, that's pretty exciting, and
that's a cool
hasn't
drone.
flown yet, and that's a very long project. And I mean, we'll see if it actually comes to fruition, but no doubt that that's my favorite drone.
I mean, that's an excellent answer. The helicopter, so it uses the same. I mean, it uses air molecules to stay aloft.
Yep.
Oh, because the gravity's less, and it can. Okay. Wow.
Yeah, exactly. Slightly lower pressure, but less gravity as well.
Okay. Well, geez, great answer. Most people say like DJI Phantom 3. I'm gonna go with Mars helicopter drone. So that's a really great answer. Now, what does the future hold then for Iris automation? I mean, looking forward, a few years in the future, where are you guys headed? Where do you want to be? What are your aspirations? I mean, I'm sure this came up in all the pitches and stuff for funding and everything, but where do you want, if you look at the company in a few years and the way the industry's headed, like what's your ideal future look like for Iris automation?
Yeah, I never get tired of talking about that and answering these sorts of questions. I mean, sense and avoid technology is exciting, and like safety systems in general for these drones are extremely important. And this is really what's gonna get us to that next level, unlock beyond visual line of sight flights, unlock fully autonomous drones. But once that is there, I mean, that's really when stuff gets interesting and stuff gets crazy on this commercial drone side. I mean, there's so many applications for drones, and all these applications I listed before, from human transportation to forestry management, or even forest firefighting. And the great thing about robotic systems like this is that right now they're relatively dumb. I mean, these autopilots they're essentially just following GPS waypoints through the sky, but wouldn't it be cool if instead of just plotting GPS waypoints to follow a pipeline, you just told it go and follow the pipeline and find me where the leaks are? Or
yes.
if you said hey, send out a couple drones and said there's a forest fire somewhere here because there's smoke in the air, go and find it, map it, and then just autonomously put out the fire, because we have a couple of these drones that are just water bombers and just filling up from lakes autonomously. I mean, this is definitely in the realm of science fiction, but also 5-10 years away.
That's where you guys are headed.
I mean, if we can build the artificial intelligence, if we can build the situational awareness for these sorts of this new generation of autonomous drones, I'm very happy to be behind that.
I like the future that you paint. Thank you so much. So everybody, you can check out Iris Automation's website at irisonboard.com. That's irisonboard.com, and follow them on Twitter at iris_automation, iris_automation. And you can follow Mr. Alex Harmsen on Twitter at AlexHarm. That's AlexHarm. And of course, while you're at it, you can go ahead and follow the podcast on Twitter at Drones Podcast, and check out the brand spanking new website at commercialdrones.fm in your web browser. It's a much better experience. I spent a lot of time revamping this thing, so I'm going to focus on putting a lot more content on there. And that's really all we have today. Of course, you can check out the Patreon page if you want to support the podcast at patreon.com/dronespodcast. I'd really appreciate that. Any last parting thoughts before we go ahead and cut off the mics, Alex?
I'm just happy to be here. Thanks for hosting me today, Ian. It's always exciting to talk about the future of drones, and I mean, I like to think that we're onto something big here, but it's also just the start of an industry. And I mean, everyone talks about all the use cases and all the good that drones will do, and hopefully we can be part of creating that.
Totally agree. Well, I'm very happy to be here too. So again, thank you, Alex Harmsen. Everybody keep an eye on Iris Automation, see what they come up with next as we get towards a much smarter drone future. We're going to go ahead and cut off the mics. Thank you, everybody, for listening. Fly safe out there. Cheers.